Today's lecture is on user-generated content, database systems, and cookies. We'll probably finish a little early because I got to run somewhere and take care of some important paperwork business in a little gap between lectures, so there's that. Anyway, let's get into it. Okay, what we'll cover first, talk about YouTube as a social media site. Then we'll talk about what user-generated content is, how people can make money off of it. We'll talk about YouTube's database systems, and finally, cookies. Okay. So, a lot of people don't really think about YouTube as a social media site, but technically it is one, and certainly one of the world's largest. It meets the operational definition because number one, lets users interact and form connections. Number two, it allows content sharing, primarily in the form of videos, but also comments on message strings and personal messages, private messages, and it has a lot of users, right? It wouldn't be much of a social media site if it only had one user, but YouTube has well over 2 billion monthly users, so there's that. Now, the reason why people may not think of YouTube as a social media site is because of how it is used, and the experience on YouTube is qualitatively very, very different from the experience on Facebook. So, typically on Facebook, people are going to connect with people they already know from real life. It would be like, hey, we're friends in real life. Let's be friends on Facebook too, right? Whereas in YouTube, not so much. In YouTube, most of the people that you might ever end up being friends with, you probably didn't know in real life. And number two, it's unlikely that anyone you meet on YouTube will actually ever turn into your own personal buddy. So, in fact, most interactions on YouTube happen through a shared interest in some kind of content category. So, for example, maybe you are trying to learn more about online streaming, right, and how to make revenue for that. So you go and start watching a bunch of different videos by a bunch of different streamers who talk about how they do it, and maybe you make friends with some of them, or at least you watch a bunch of their videos and learn how to do it, right? So to the extent that a connection happens, it'll probably be through some shared interest like that. And in fact, many YouTube users never do any of the social stuff to speak of, right? They never post content, never directly interact with other people. For my part, I've been on YouTube for something like 15 years, and I have literally never put a comment on after a video. I've only started actually posting anything in like the last few years when I started uploading videos of my lectures and a couple other things. So yeah, for a long time, I was one of those people who was like a permanent lurker. Okay. Now, user-generated content, or UGC, is anything created by system users and made public. So things like comments on message boards, comments underneath a video, whatever, blog articles, anything that you upload, like photos or videos uploaded to YouTube, Facebook, wherever, that's all different kinds of user-generated content, right? It's something originally created by one of the system users, not by the platform itself. And for the vast majority of UGC, immediate profit is not really a motive, right? People tend to create UGC not out of a desire to make money. So, for example, you go on vacation, then you go take a bunch of pictures there, you come back, you upload the pictures to Facebook, you share them with your friends, right? You're not doing that to make money. Or you go on some message board, right? So, for example, on Facebook, I have a number of hardcore libertarian friends, and I have a number of hardcore anti-libertarian friends, and it's sometimes entertaining to see them argue, right? Why they do it, I don't know. They've already said all that they have to say about it to each other like many times over, but they still like to get in and argue, and nobody's paying them for that. And finally, of course, just socializing with people with similar interests. So that's something that people do. So anyway, UGC, most of the time, it's not about making money. It's about some other non-cash incentive. Now, comparison of Facebook and YouTube. So on Facebook, individuals are going to build and strengthen their connections through sharing content. For example, you have some distant relative you don't see very often. You post up some family pictures that you just got taken. They say, oh, that's great. The kids are growing up so fast. And you say, yeah, I know. Come look us up next time you're in town. And they say, yeah, sure, we might. Right? You're strengthening your connection through sharing content. Otherwise, your distant relative might totally forget about you. Again, a lot of this user-generated content is typically created for its own sake, right? So if we go somewhere, we have family pictures, we upload them to Facebook, We're not doing that to make money, right? We're doing it to share with our friends and have a place to store it, one more place to store the pictures. And of course, on Facebook, individuals rarely monetize their connections. So every now and then you might find somebody on Facebook who's trying to make money off of people. They'll do something really annoying like, oh, we're trying to sell Tupperware, and if I make just $20 more in sales, I'll be able to afford this vacation to Hawaii. And it's like, no, I'm not going to buy Tupperware from you. So yeah, people sometimes try to do it, but it's unusual and it's annoying. Businesses, of course, on Facebook, they monetize their connections all the time. They have a Facebook preference because they're trying to sell something. For YouTube, on the other hand, with YouTube, individuals do often post content that can build connections, but typically not close personal ones. For example, suppose you're LaserBeam, right? And you post lots and lots of videos in a hope to make money off of it, and people subscribe to your channel and they like what you do, and that's great. But none of those subscribers are probably going to be LaserBeam's buddies, right? He's probably not inviting you down to Australia for Christmas dinner. That's just not going to happen, okay? So yeah, you can build some kind of connection, but typically it's more of a fan versus a celebrity connection, not so much like your buddies or equals. And monetizing those connections is standard, right? You expect that all these people that are streaming or otherwise producing a lot of content on YouTube, yeah, they're trying to do it to make money. They run ads along with the videos, they make some money, that justifies them keeping on producing content. And over time, individuals can become sort of brands for their content categories. So there was one woman about 10 years ago who went by the YouTube name Disney Collector. Right? She had to change her name then because Disney got upset about it. But she was one of the early unboxing videos. You guys know about unboxing videos? Yeah, so that's what she did, right? And when we had like 2-year-olds, they could just sit there and watch that stuff endlessly. And she was making like $5 million a year at one point just doing unboxing videos. So it was like, oh, look, it's Peppa Pig, and here's a little truck that she could ride in. Woo! And $5 million a year. Yeah. Okay, so anyway, on Facebook, the focus is people. You show up and you absorb content because you like the people that created it, right? You're paying attention to them. For YouTube, the focus is primarily on the content. You show up to watch an entertaining video, you kind of don't care that much who made it. I mean, sure, some people become brands and they're reliable providers of interesting or entertaining content, but it's not like at the end of the day, you're best buddies with Mr. Beast or LaserBeam, and probably not that concerned with them personally, right? If they make funny stuff, though, you'll watch it. Okay. Now, next thing, advertising. So way before the internet, so think, circa 1990, before the World Wide Web, advertising typically went one way. They gave out a message and the customers could either ignore it or absorb it, but it was really hard for them to effectively dispute it. So an example. When I was in Switzerland for a research internship about 15 years ago, and I saw a lot of trucks for Carlsberg beer over there, a lot of delivery trucks for Carlsberg beer, and the slogan at the time was quite possibly the world's best beer, and they had it printed on all their trucks. And this is in marketing what's called puffery, all right? So puffery is a claim that nobody's going to take too seriously, but everybody understands that a business is trying to sell its products, right? So when you say that, it's not exactly a lie for Carlsberg to say it, but it's kind of like, well, yeah, they're advertising for their beer. What are they going to say? It's not that good, but it's available in stores now, Right. So everybody understands that that's kind of how advertising works, right? So this was very good for controlling the message because, if they repeated it often enough, hopefully people would start to believe it, right? But of course, people who see that advertising, they don't really trust it, right? They understand that at best, it's just telling the advertiser's side of the story. So even if the customers listen, and they might not be paying attention, but they're going to be skeptical. They're going to say, yeah, okay, maybe Carlsberg is fine, but what else are they going to say? Now, when social media came around, it allowed a certain extent of two-way communication. Basically, the business could introduce its product, and somewhere on some page it could say, hey, tell us what you think, right? And the ideal is a lot of people come in and they talk about how great the product is, and those people are, neutral, disinterested, unaffiliated with the advertiser itself, and so people take their word as being credible, right? So, for example, if Carlsberg tells you their beer is great, you're going to be like, yeah, whatever. Of course you're going to say that. But if you have a buddy who's like a full-time beer guy and he tells you, man, Carlsberg, it is so good, you have got to try this, you might be like, yeah, okay, I'll go to the store and buy a 6-pack. Let's see how it is, right? You might trust that. So that's what the advertisers are trying to get, right? They're trying to mimic word of mouth from unbiased users so that the people who hear it consider the message more credible. Now, problem is, when this fails, this can fail spectacularly. So, anybody know who Bill Cosby is? Bill Cosby, right? So Bill Cosby for decades was a very famous and talented entertainer in a variety of media. I actually grew up listening to some of his spoken word albums. And then, you know, he was in movies, he was in TV, maybe most famously for The Cosby Show or Fat Albert. He did the Fat Albert cartoons. I watched them when I was a kid too. Anyway, but around 1990, The Cosby Show was the top-rated program in the United States, or the top-rated comedy anyway. And it was a big thing. So around 2010, 2015, somewhere in that window, they started talking about doing a reboot, right? I mean, people were 20 years older, so I guess Bill Cosby was going to be the grandfather at that point. But they were talking about doing a reboot. And around at that time, there was a comedian in Philadelphia, who made reference to, oh yeah, they're talking about bringing the Cosby shows back. You know, he's America's dad. He should be called America's rapist, right? Because in case you haven't heard, there were decades of sexual assault allegations for which he was ultimately convicted. Anyway, so these had happened for a long time, and you know, basically they were settled out of court or whatever, and they kind of never went anywhere. But what happened when this reboot was in the works, right around that time, that whole thing of that comedian saying that went viral because a lot of people heard it and they're like, no, not Bill Cosby, not America's dad, what the hell? And, you know, they looked it up and they're like, oh my God, look at all this. And around that time, the network, I think it was NBC, was saying, hey, here's funny memes of Bill Cosby, you know, him doing a goofy face and you put some text on it. Well, needless to say, many of the things that were written in those memes were unkind and unfortunately probably true. And so the whole product just kind of imploded at that point. And, you know, yeah. So anyway, when this happens, right, when this social media stuff explodes and goes bad, it often goes very, very, very wrong. So that's the risk. Okay. Now, branding yourself. So this brings us, you can brand yourself on YouTube. How would you go about doing that? Well, the first thing to understand is that most people would much rather watch TV than read articles or books, right? Meaning, if you have a choice between blogging and YouTubing as a way to create user-generated content as a way to make money, right? So 20 years ago, yeah, blogging was kind of a thing because streaming video kind of wasn't a thing yet. And so a lot of people are out there saying, yeah, I'm unemployed, but I'm going to start a blog and try to make money off of that. But problem with blogging, number one, it's a crowded space, right? There's a lot of bloggers out there. You have to convince people in some way to come to your blog and read your stuff. Yeah, good luck with that. It is very hard to go viral or build a large following, you know, and especially if you're an unknown person, right? If you're somebody who doesn't really have any credibility in the field, nobody's going to pay attention, right? So like me, I've taught Java courses, programming language, and I could write blog articles about, you know, how to learn to code in Java, but you know, I don't have any cachet within the system, right? It's not like I'm one of the guys who wrote the programming language, or I'm not like a top guy at Oracle or Sun Microsystems that, you know, have owned Java at various times. Nobody's going to see my name on a blog and say, oh man, I got to hear what this guy says. This guy knows it, right? So yeah, if you're unknown, it's very difficult to make much money as blogging. I don't recommend it. So YouTubing, on the other hand, I remember the first time my son said, oh, so-and-so, he's a tuber. And I said, he's a potato? No, and then, yeah, dad jokes, right? Yeah, anyway, with YouTubing, an entertaining video, especially for underserved search terms, market segments, can possibly become a hit. So, are you all familiar with It's Corn? Oh my God. It's corn. Cool. A big lump of knobs. It's corn. So if you haven't heard it, you're about to hear a little bit. I like the subtitles. It has the juice. All right, so you can watch this on your own time, but the point is it exists, and 24 million views. Okay, remember that number, close to 25 million. All right. So again, we didn't really come here to watch It's Corn, but 24 million views, right? Well, let's break that down. If we assume as a reasonable number, $5 per 1,000 views, and we're going to multiply that times how many views? 24,000 views is going to equal how much? 5 times 24,000 equals $120,000. Okay? So I know the kid didn't get all that, but I also know the kid had to have gotten a pretty good chunk of it. So just saying, right? And this, what happened is the kid did some interview and, you know, it kind of went viral. And then somebody said, hey, let's make a song. And they made a song and there it is. Okay, history happened. You guys may also remember from some years ago that Friday song. Anybody remember the Friday song? It happened, right? I forget the girl's name, but there was some, you know, teenage girl wrote this song about Friday. Was it Rebecca Black? That I was going to say something like that. Friday song. There we go. Friday song. Rebecca Black, there it is. 163 million views. So she has quite possibly made close to $1 million off of that thing. Just saying. Okay? Anyway. Video views well into the millions are not uncommon, even for amateurish productions. I brought up Sidewalk Cops before. They have many, many, many hundreds of millions of views and have surely made bags and bags of money off of those as well. So, if you're lucky and you hit that going viral lottery, yeah, ka-ching. Okay. Now, YouTube revenue model. So number one, obviously, it's primarily by ads. There's other revenue things, right? You can do a pay-per-view event, or if people have opted into one of the premium YouTube services where they pay a subscription, but they don't view ads, some of that subscription money can, you know, be split among video producers. So there's same as Spotify or like the Amazon Dot, things like that, that kind of system. Anyway, videos can be preceded by, be interrupted by ads. When our kids were watching a lot of Peppa Pig back in the day, we'd find these 2-hour marathons, right? 2 hours of nonstop Peppa Pig, and every 15 minutes or so, there'd be a little block of ads in the middle. So, you know, you'd have to wait. Yeah, so it's like your commercial break. Anyway, the typical model is that if a viewer clicks on an ad, you get paid. They can also do pay per impression, same as Google Ads. Now, YouTube obviously has a concern over copyrights, not so much that people are putting stuff on YouTube, but over the concern that people are making money off of putting stuff on YouTube. So early on, there were a lot of people that, you know, were basically converting VHS tapes of things, music videos they taped off of MTV back in the day and uploading that to YouTube, trying to make money off of it. So early on, YouTube was packed with users trying to monetize non-original content. So YouTube came up with a database system that says when someone uploads a video, YouTube is going to check it and make sure, hey, does this thing already exist on YouTube, and do we know who the copyright holder is, right? If YouTube doesn't know anything about the video and nobody seems to be the copyright owner on it, then they're going to assume it's user-generated content. Okay, now the way this works, if you've ever used the Shazam app, anybody use Shazam? Yeah, some people know it. So Shazam is an app that if you're out there hearing a song and you're like, hey, that's a neat song, I wonder who does that. You can open up the app, let your phone listen to it for a few seconds. It'll take that slug of sound, send it to a database, and try to recognize what song it is, right? That's what Shazam does. And YouTube does a very similar thing, right? They take snippets of the video and they compare it to existing stuff. Now, sorry. As far as options, right? So for copyright violation, the principle is you cannot earn ad revenue from other people's content, okay? It doesn't always work out that way. Not 100% followed. Some nations are less strict about copyright violations, right? So, but in general, this is YouTube's philosophy that if you didn't create the content, you shouldn't be able to make money off of it. So, if you do post a video created by someone else, the copyright holder has these options. Number one, block the video entirely, right? Say it's not yours, you can't show that. Number two, let the video run, but also run ads with it and keep all the money. Okay? They might say, you know what, this copy of the video is actually pretty good and a lot of people have watched it, they probably favorited it. Sure, we'll let this stay up, but we're gonna run ads on it and we're gonna keep all that money, right? Because you don't get it. Or number three, do nothing for now, decide on something maybe later, right? The copyright holder doesn't have to immediately make a decision and live with that decision forever. They could say, you know what, this video, it's got like 10 views. It's not even worth calling up our lawyer to do a cease and desist at this point, right? But yeah, we'll keep an eye on it. Maybe, you know, we'll do something with that later, okay? And YouTube, of course, doesn't want to deal with the legal headaches, right? Once upon a time, there were a lot of, you know, cease and desist orders to block videos, but, you know, lawyer time is expensive and nobody wants to spend there. Okay, so YouTube tries as far as possible. They try to automate the copyright checking process. And of course, there's an arbitration process. There's a resolution process. If you feel like your video has been unfairly tagged or there's something you're using under like fair use that shouldn't have been caught by the copyright violation people, yeah, you can have a discussion about that. But in general, you should not be able to make money off of other people's content. Okay. Now, earning. Some people make quite a bit. I heard that Mr. Beast, if you've heard of him, I heard he made $50 last year through YouTube, which is kind of crazy. And Laserbeam, who's another one of my son's favorites, Laserbeam apparently has a net worth of 150 million despite being a high school dropout, which suggests we're all in the wrong line of work here, but yeah, anyway, some guys are making a lot of money off that, right? And I got some lists, other people, if you're interested in those links, you can see a lot of people have made a lot of money doing various things, right? Sometimes with art, sometimes with being funny, sometimes with streaming video gameplay, all that things. Okay, anyway, rule of thumb, first you make the content, right? Then you get the views, you get the subscribers, and then eventually, if you're lucky, you can get some money. So typical income, maybe about $5 per 1,000 views. Now, of course, that can vary wildly, right? Number one, it depends on how many people are clicking on your ads. So there's that, right? And some ads pay better than others. So there's also that. But if you want like, you know, a rough estimate of where a typical video would probably end up, yeah, about $5 per 1,000 views. Okay. Now it tends to taper off as the view counts climb to maybe something like 2,000 or 3,000 per million, right? Which would be about $2 or $3 per 1,000 views, is where it kind of tends to, you know, balance out. And the reason is a lot of those are views are going to be simple repeats where maybe people don't see the videos again, for example, don't see the ads again. So that can happen a lot too. If you read the articles, if you read the links in there, there's some stuff it's a little confusing in places. They talk about different revenue models. So it's not just, you know, regular ads, but you could set up your video as a pay-per-view event where you charge people to watch it, or there are, you know, basically premium tiers of money you can get from YouTube. And of course, if you're a very popular video, you can get a chunk of YouTube subscription fees for the people that do that. So there are different revenue streams, but again, typical numbers, a few dollars per 1,000 views. Okay. Now, as far as presentation, YouTube, you can think of it in a lot of ways as being the same as Facebook and Amazon. So just like Facebook, it wants to show you content that has a proven history of interaction. They want to show you content that other people similar to you have previously interacted with. And like Amazon, they're going to try to pull that content that people like you have actually clicked on, right? So it's very similar to both. And doing this sort of model takes a couple things. It takes, number one, an initial baseline, right? YouTube has to develop some profile of what it thinks you might be interested in seeing. And then over time, it's going to continuously update that as it learns more about you, right? So over time, your profile will change, right? Maybe your video tastes change, your music tastes, whatever. You could watch something like that. So hypothetical example, right? Suppose you're on YouTube and you know, you're doing your usual stuff in 2021. You're just watching videos and, you know, music and stuff. And then the war in Ukraine happens and you have family over there and suddenly you're spending a lot of time on YouTube trying to watch kind of live stuff there. Your profile is going to change, right, as far as YouTube is concerned. Number two, new video releases. So there's new videos being released all the time. Some of them you're going to watch, most of them you're not going to watch. YouTube's going to incorporate that sort of information into your profile and into the possibilities of what it can show you. And in this case, immediate consistency is not terribly important, right? So we talked about ACID properties. ACID properties aren't that important to enforce here. It just doesn't matter that much. Not everything has to be super up to date as far as this. You can do some kind of batch update at the end of the day, because most people's viewing habits, they don't turn on a dime, right? It's not like Saturday morning you wake up and you're listening to classical for like the whole prior year, and then Sunday morning you wake up and you're like, well, I'm the world's biggest Katy Perry fan. Let's just do that all day, right? Life doesn't usually work like that. So most of the time, you know, there can be an acceptable amount of delay as profiles drift. All right. Now, on YouTube's landing page, and by landing page, I really just mean the home page, youtube.com. Landing page is kind of an older equivalent for home page. When you first visit YouTube, you'll get some kind of standard mix of whatever content is locally popular, right? So suppose you get a brand new machine, you walk over to Best Buy and you look at the laptops they have before you go buy the one on Amazon, right? And then you buy the one on Amazon and you go to YouTube and you don't log in, you're just there with a new machine. Okay, they want to show you stuff that they think, oh, typical user around Chicago is going to want to see, because they don't have any other information about you. That's the best they can do. So just like Amazon, YouTube wants to make it easier for you to find interesting content, right? They want to show you people like you looked at this content. And just like Facebook, they want to show you a customized mix of interesting content, right? They want to show content not just that's interesting to people in Chicago, but stuff that they hope is actually more interesting to you. But of course, until YouTube knows what you want to watch, they can't do much about that. If the only information they have is that you're some user near Chicago, well, that's the best they can do. But each time you view a video, YouTube's going to track that action, it's going to add it to your history in some sense, build your profile of all the things you've watched, and over time, they're going to have a pretty good idea of the stuff you like to see. And applying that sort of continuously updating profile information to your video options, that's a kind of learning. The machines are gradually learning what sort of content you want to watch. Okay, so you go to YouTube first time around, it'll probably show you a random mix. There'll be some popular music videos, there'll be some late night TV clips, there'll be some sport things. You know, there might be some kind of do-it-yourself type videos, whether it's about art or personal finance, be some news stuff, whatever. And they'll say, okay, which of these things do you like? And over time, you'll, you know, build a better profile, give you better recommendations. All right. So talking about learning systems generally, the basic idea with learning systems is they start with some default baseline, gather relevant information over time, and eventually, hopefully, they gather enough information to make a good solution to some kind of knowledge problem. Now, an obvious one here is machines that play chess, right? So when I was your age, many years ago, the machines were just starting to overtake the humans. But now, anybody know who Magnus Carlsen is? Yeah? All right, everybody knows him. Well, Magnus Carlsen, in case you don't know, is probably the strongest human chess player who has ever lived. And even he is pretty helpless against the best machines, right? Some of the programs like AlphaZero and some of those, I was pretty good back in the day. I played in tournaments and stuff like 30 years ago, but the gap between Magnus Carlsen and the top machines is just about as big as the gap between me and Magnus Carlsen, which I might add is tremendous. Okay? So that's no joke. So even the strongest humans are like pathetic little worms against the best machines in the narrow domain of playing chess, right? Now, for YouTube, the way this works, the set of locally popular videos is the baseline. If all YouTube knows is that you're in Chicago, boom, average Chicago profile becomes your default baseline. Successive user actions, like which videos you watch, how long you watch them, give YouTube more information about what you might want to see. And every time you visit, YouTube is going to give you its best guess about what you'd like to see. Okay, now YouTube does what's called machine learning, and this has been a very, very big thing in the last 10 years, used in a lot of different ways. If you ask the wrong people, you could get into a big argument about whether machine learning is a kind of data mining or whether it's merely a close cousin of data mining. But this is IDS 200, so we don't need to get into that battle. But what we can do is it's a similar type of predictive technology, right? You have some set of data, you run that data through a bunch of processes with some math, and you come out with some prediction outcomes on the other side. Now, the thing about machine learning, fundamentally, it produces a bunch of rules for predicting an outcome, okay? And this makes sense in chess, that you could say, you know, control of parts of the board is more important than control of other parts of the board. Certain piece configurations are more powerful than other piece configurations. Certain pieces, like a queen, is almost always more powerful, more useful than a knight in chess. Things like that, the machine gradually absorbs by by playing games against itself millions and millions of times. Applying this to YouTube, for example, suppose I have put up a set of 4 videos for the YouTube module, right? And suppose that among the tiny fraction of people on YouTube who actually view my videos, a lot of people who view the first 3 in that series also view the 4th one because they want to study for the final, so they watch the videos, right? So YouTube would come up with some kind of machine learning rule that says, you know what, if a user has watched videos A, B, and C, they are very likely to also watch D, right? Whereas the probability of an ordinary user, somebody who just randoms onto YouTube, their probability of watching that video D is pretty much 0, right? There's, again, a minuscule fraction of the YouTube viewers are actually looking at anything I post there. Now, YouTube also has a 2-stage recommender system, right? So again, think Amazon, think people who bought this also bought that. YouTube's model, first, it has to pull a subset of several hundred videos out of, you know, maybe close to 1 billion or billions that a user is going to be predicted to like. So YouTube has this massive pool of videos. From those, it's going to pull some subset that are promising candidates, and then it's going to rank them and return the ranked list, right? It's going to show that when you're watching a video on YouTube, it has a bunch of recommendations on the side of the screen. What does this sound like? What does this sound like? Pulling several hundred things from a batch of billions of things and ranking that list? What does that sound like? It sounds a lot like Google search, doesn't it? Yeah. It's not really a surprise that, you know, YouTube and Google are closely affiliated, right? But this model works pretty well. And it's the same idea, right? I would have also accepted Amazon. Amazon's recommender system is a similar thing, but the math for doing that for Amazon is a lot simpler, right? If you look at people who bought this also bought that, that's a pretty simple computation to make, right? This, trying to figure out based on all these different factors, people who like these videos are going to like these other ones, that's going to be a lot trickier, right? That's not something you're going to slap together in your garage over the weekend. So anyway, there are some challenges to this. Number one, scale. as the system gets bigger, it's just harder and more work to manage the whole searching and ranking process. Number two, freshness. So with freshness, you're caught in the in sort of a trap where if you have more data, you can get more accurate predictions, right? Because your sample error is less. Like, go ask 1 million people who they're going to vote for, it's probably going to be more likely to the actual result than if you just ask 10 people who they're going to vote for. Okay, same kind of thing. So if YouTube has more data going backward in time, then yeah, they're going to be able to come up with more accurate predictions. But the problem is people's video preferences change, right? Especially when you're younger. So if you're old like me, then your music tastes do not change much, right? There might be some new song or some new soundtrack that comes out that you really like and you listen to that a lot, but the kind of style of music you're going to listen to, that's probably not going to change that much by the time you're older. But if any of you look back in time and said, think about the music you listen to now versus the music you listened to 10 years ago, there's a very good chance that it is very different now. And that's sort of the freshness problem, right? If you go back in time far enough, some of that data is going to be pretty much irrelevant. In fact, even not worse than irrelevant, it's going to be actually directly contradictory to your current preferences. And there's then the noise issue. Noise is data that just doesn't make sense, essentially. So for example, suppose you are me and you have some batch of music that you listen to fairly regularly, right? You like put on YouTube when you're working out on the elliptical or in the gym or something, and that's fine. But then your kids invite a bunch of their friends over and they want to all have a big dance party in the living room, right? So you put on a lot of like bouncy poppy music that's not really your thing to listen to, and that's fine, but you would not want that to be permanently included in your YouTube profile. YouTube's going to think about it for a while, but if it's kind of like a one-off thing, they're going to say, oh, yeah, that's just some noise. That really doesn't, fit in too much with his real profile. Okay, so anyway, we understand sort of how learning works, what the goals of it are, and we can understand in a big picture kind of way that it's not as simple as just saying people who like this also like that. It's a little bit more of a sophisticated algorithm than Amazon's. Okay, now we've also talked about self-reinforcing popularity, right? Where some things become popular, they maintain popularity because they're popular. We talked about that with Google Scholar back when. So to deal with that, YouTube tries to experiment by including a small random factor in its recommender system. Reasons, there's a bunch of benefits from that. Number one, it can suggest interesting but hard to find content, right? If there's some little oddball video that a small cluster of people really like, maybe you'll like it too. Number two, lets trending videos compete against older ones, right? So suppose it's 2011 and you've been listening to a lot of Lady Gaga and Kesha for, the last few years, and all those videos have like view counts of like 200 million, 500, whatever. If a new video comes out, it's going to be very difficult for that video to get the views to compete with those unless people specifically seek it out, right? So YouTube is going to say, oh, this video, even though it doesn't have as many views as these other older ones, it definitely has a lot more views in the past week. So we're going to, give that one a chance. Maybe you want to listen to that one. Also gives more knowledge about user preferences. So part of how YouTube decides what random bits to show you in the options is basically, hey, we'd like to know more about you, right? Here's a little test we can see. Do you want to watch this video or not? And maybe in YouTube's algorithms, that's somehow important. And of course, if your preferences change, that allows a quicker convergence to those preferences, right? Maybe YouTube says, oh, we never knew that you had an interest in, say, videos about carpentry, right? How to do some do-it-yourself carpentry, but we randomly showed you one, you watched it, you thought it was interesting, you watched a bunch more. Great, now they know that about you. But the deeper purpose, of course, is to break out of those kind of circular loops where content remains popular because it used to be popular. And without randomization like that, recommendations can easily become too much tied up by their own inertia. The videos that have a lot of views get recommended because they have a lot of views, and they keep on getting more views because of that. All right. Now, a couple articles about databases here. These are really optional reading. If you're interested, that's great. The first one, YouTube has a bunch of interesting modifications to its database system. If compared to a standard relational one. So Oracle, which is, the big provider of enterprise scale relational database systems, this is an article from several years ago saying, yeah, if you were YouTube and you want to do all the stuff that YouTube needs to do as far as managing a lot of data and making sure that there's lots of simultaneous access possible to that data, and you wanted to do it using Oracle system, it would be prohibitively expensive. There's like no way you could actually do it. So YouTube had a very good set of business reasons for modifying its system. Some other stuff, this is an old article. It's literally 10 years old, but the principles in that article do not change. And the big thing, some data needs to be consistent, a lot of stuff doesn't. There's a lot of corners you can cut. So, for example, suppose there's a very popular video that is generating 100 million views a day, right? For whatever reason, it's it's a big thing and everybody's watching it. If YouTube has to manage every one of those separate view updates, those upticks on the view count as a separate database operation, that's going to slow down their system, right? If YouTube insists on ACID properties there's no way the system's keep up with that. It's just too much. So what does YouTube do? YouTube says, you know what? It doesn't matter if the counts are precise. We can have some other system, right? We can just keep in RAM, we can keep a count of how many people have watched that video and tick that up over time. And every now and then, like every 5 minutes or every hour or at the end of the day, we can update the video view counts with that information. So we don't have to do every tiny little one. Or we could just say, hey, you know what? This video tends to get about 1 million views per day. We're just going to assume that that's on track for this day and update that count throughout the day at that rate. And at the end, end of the day, we'll correct for any shortfall or overage there. Okay, so one of the lines in the article, memorable lines in the article, is the fastest server call is one that doesn't happen, right? So if you can just do some math to update that view count instead of sending a message to a database, having the database look stuff up, having the database respond back to you, it's going to be a lot faster. Just do some math in RAM. Okay, so that's one of the corners that can be cut. All right. Now, YouTube has a database system called Vitesse, and if you know French, you will recognize that that is a misspelled version of vitesse, the French word for speed, right? It would have an E at the end if it were the correct thing. So, Vitesse is a relational database. It's an extension of MySQL. MySQL is a relational database platform, and Vitesse basically adds on some new features. So I'm gonna talk about one of the new features that will make sense. All right. I hope it makes sense anyway. So, with search queries, YouTube will often see that one query's results are contained in another, right? So, for example, top songs of the 2010s would contain all results from top songs of 2012, right? We can agree on that. So if YouTube had the query results for top songs of the 2010s already cached in RAM, it would not need to do a separate database query to get the results for top songs 2012, right? Because all those videos are already there cached in RAM. It just has to figure out which subset of videos to provide, okay? So that sort of thing, that sort of smarter query arrangement, that's one of the things that lets YouTube work a lot faster. Because again, this kind of stuff, you know, if you include, for example, pop songs 1980s, right, you're going to get a lot of Madonna, Prince, whatever, you know, who else? I don't know, George Michael, I guess. A long list of dead people. Billy Joel, I would accept Billy Joel. One of the few survivors of that era. Although I considered him more of a 70s guy, but he did sell a lot of records in the 80s. Anyway, you get the idea, right? So if you do a search for that, pop songs of the 80s, it's probably going to have like most of Madonna's biggest numbers. And if you look for some other songs, right? If you look, I don't know, I'm trying to think of a Madonna song from the 80s. Or how about Papa Don't Preach, right? It's hard to believe that, in case you don't know, Papa Don't Preach was a Madonna song from the 80s where a girl gets pregnant and decides to keep the baby even though, it's maybe inadvisable. And I thought to myself at the time, how is this even a song for the clubs, right? What could possibly make two people less likely to want to hook up in a club than a song about getting accidentally pregnant? Just saying. Anyway, all right. Those were the 80s. Okay. Second thing you might ask, why is a relational database system even viable, right? One of the things we've been talking about is how video data is really hard to store in a relational database, right? Because some video files are very big, others are very small. You have to allow space for the biggest possible video in your database. It's going to create a lot of problems. Well, one thing is that YouTube stores video metadata in fairly standardized formats. So there'll be things like the name of the video, the artist, when it was made, how long it is, what the format is. All that stuff is going to be a pretty standardized format so they can get reasonably high utilization on their database storage. The other thing is Dash. Dash delivers videos as segments, right? So YouTube doesn't store the entire thing as one big file. It stores it as a bunch of different video segments. And those segments can be held to a standard size, right? Which again allows fairly good utilization in whatever database table those segments are stored in. So that's good. And then the follow-up question ought to be, okay, fine. You've made a good case that a relational database is at least feasible for YouTube, but wouldn't that mean if we're not going to use NoSQL, what are some problems with using a NoSQL database? Well, as always, glad you asked. That's a great question. First thing is compression, right? So if we were just storing video as entire complete documents, as entire complete files, yeah, we'd probably use some kind of system like Amazon's S3, some kind of key value store where every database record can have its own custom structure because that's most efficient in terms of storage capacity. However, videos are stored in compressed form, right? And if you have a compressed video and somebody wants to start playing the video midway through, you have to decompress the thing to figure out where exactly you're going to be at that point. That's a problem. So yeah, unless you're storing it as segments, you basically have to pull the entire video file, deliver it, and then figure out, oh, here's where that person wants to be like 1 minute into it. It's going to be really hard to do that. And even if you do manage to do that, it's going to be a lot of extra storage work that's going to make it actually harder to use a NoSQL system. So I'm not saying you couldn't use it, but the fact that data is often compressed for videos means you'd have to do more work in a NoSQL system. What's that? No? Okay. The other thing, table joins. So remember, database join operations, that's where you have a query that brings in data from more than one table. You kind of join the two tables together. And those are very often included in a video search process. Now again, the number of table joins you can do in YouTube are somewhat limited, but they're still there because you often have questions like, show me all the videos by a particular artist, or show me videos from a particular album, or show me videos uploaded by a same user, right? And that information is going to be stored in different database tables. You need to be able to do some table joins. And if you're doing that in a NoSQL system, what that means is, since every record has a potentially unique format, you have to scan through each record to try to find those fields that you're looking for and see if they're even there before you can do that kind of join query operation. So again, yeah, you could do it. It's just going to be slower. So the relational database, provided they have put in some new features to make it run faster like they have, and provided that the video data is segmented into same size chunks, then yeah, relational database actually works really well for YouTube. Okay. Questions on any of that? We're saving them for Thursday? We're saving them for Thursday, okay. Our last topic is HTTP cookies, or just cookies. We're going to just call them cookies mostly. We'll talk about what HTTP is in a moment. So cookies are small files stored in your web browser by a lot of different sites if you let them. These days, you have to explicitly give permission for a website to put a cookie on your machine. The way it usually works, one cookie per profile, browser, and even website combination, right? So in general, websites are only going to put one cookie on your machine. The cookies are stored separately for different browsers. So if you're using two different browsers on a machine, they're going to have their own separate sets of cookies maintained. If you have different users who have to log in to use a machine separately, they're going to have their different cookie batches as well. Okay? And in particular, they do not store information to identify users across devices. That stuff has to be managed on the server side. So for example, if Google has a cookie on your machine and you log into Google and your cookie data gets uploaded to Google, then Google has it, and the next time you go to another machine, Google can update the cookie on that machine with the information it already has. So it can always do that, but that's what it has to be. It doesn't happen with the cookies, it happens on the server side. So cookies have some standard elements, right? There are some things that are commonly stored in there, but basically a cookie is a big unformatted data file up to about 4K, and you can store any information in there that you want to. So data in a cookie is typically either stored as plain or encrypted text, right? It doesn't have to be stored as text. You could do it as like some sort of numeric whatever if you wanted, but most of the time, yeah, it gets stored as text or it gets encrypted so it looks like text. If anybody is still using Internet Explorer and nobody is, there's a folder you could find the cookies. For other browsers, you find them somewhere else, but you know, they're basically there in your browser folder. Okay. This is an example of 3K of data from a cookie file. So the max data on a cookie is 4K. So this gives you an idea of about how much data you're talking about. So, you know, a few pages of ordinary text. And if you look closely at this, most of this is gibberish. It's encrypted. You can't really figure out what it says. There's a few spots on here you can, though. So I lifted, this was actually a cookie on my machine from a site called UGC that I visited. It was the first one that I saw in my browser. And I changed a few things on the off chance that there's something in there that's somehow useful, which there probably isn't because it's like from 2015. But I changed the A to a Q, and you can see down here at the bottom right, it says UGC. And there's some other things. There's the visitor ID. It has something. There's the date here starting at the top line, 2015, December 30th, you know, such and such time. Okay, so there's going to be some stuff in there that might be plain text, but the vast majority of it, yeah, it's probably being encrypted somehow. Okay, and we'll talk about why. So first of all, how cookies work though. So when you visit a site, it's going to ask to install a cookie on your device. And if you let it, it's going to put some session information there. So the thing I did this morning, I went to slither.io. You guys know about Slither? Of course you do. Who wouldn't know about Slither? All right, so we go to slither.io. And I set up my account. I was logged in as Evil Cactus. But even if I haven't logged in, I can change my skin. And I start with this default green one, right? That's mine. Now, if I want to change it and go to a different color, I'll be Earthworm Sally. All right, let's stop that. And I can close out, and I can come back later. Notice I never logged in, right? But the cookie maintains my information. Let's see. If I go to change skin, there it is. I'm still Earthworm Sally. Okay, that's how cookies do it. Now, so when you visit a site, it's going to install a cookie on your device that has session information about you. In this case, you know, my worm pigmentation. And if it's a site that has multiple pages and requires a login like Facebook or something or YouTube, you can use that cookie's data as proof of login to access other pages. Basically, when you request a new page from the server, you send along the cookie data so that the server can recognize, oh, that's you. I know who you are. I'm going to send you the page formatted, you know, however you need it, with content that you're able to access and with your viewing preferences, like you like to be slightly zoomed in, whatever. Okay, and so for subsequent visits, won't need to provide that information manually. When I went back and visited Slither again, instead of my worm being green, it was now sort of that earthworm color. Anyway, typical stuff stored in cookies, user ID and passwords, site preferences, any recent user history, like if you go to Amazon and you've added something to your shopping cart, or if you've gone to YouTube and you've watched some videos, it might track that. Oh, you watched, you know, that one like 2 minutes through. You come back a few hours later and it'll still remember that you watched it 2 minutes through. Stuff like that is what you use for cookies. Okay, what you use cookies for. Now, why do we need cookies? Well, The reason is many web applications are what are called stateless. So state in this sense means like the general state of things, right? So the way things are. So stateless applications don't track information about users, meaning in a stateless application, if you go to the website and you ask for a page, it's going to deliver that page to you the same way as it would for any other user, regardless of what any of you users were doing or had done in the past. That's what stateless means. But stateful applications can track user actions and somehow modify what they do in accordance with that. And again, stateful applications are very, very useful, right? If you go to Facebook, you want Facebook to remember who you are. You don't want to have to log into Facebook every time you go back and visit, right? So in a stateful application, you send the cookie information. The cookie information lets Facebook know that, oh, that's you. Great. I'll deliver the stuff that, is accessible to you. And originally, HTTP, Hypertext Transfer Protocol, that is a method for sending data over the internet, it was stateless because it was faster. The reason is if a request comes for a web page, that means the web server doesn't have to do a whole lot of calculation and searching about which version of the web page you should get or how to construct it, right? It was just, oh, do you want that web page? Great, I'll give you that web page. But eventually, a lot of operations started including stateful features, again, like Facebook, like Google, like YouTube, like Amazon. So typically, a server receiving requests over the internet wouldn't know if any had the same source, right? That information, if it's there, would be kept on the server side. You would say, oh, you're such and such user. To get to that information, you have to log in first. But it's very often much more scalable to do that on the client side. So imagine you're a very busy site like YouTube. You don't want to make people have to log in every time they start a new video. You don't want to have to manage that login stuff on every page every time somebody goes to a new page to watch a video, right? It's better to say, yeah, we're going to store that information on your machine. We don't want to have to quickly update your profile for every little thing you do. We're going to store that on your cookie, and we'll eventually get to updating our system. So if you're doing a lot of that work on the client side with cookies, it's going to be a lot faster than if you have to access your data repeatedly for a lot of your databases repeatedly for a lot of small questions. Okay. Now, HTTP cookies are limited to about 4K of data, which is not very much, right? Think of it as being about a few typed pages. Maybe they say 1K is about one typed page. There's probably more like 2 typed pages now that fonts are smaller, which is going to be very limiting for some applications, right? If you're thinking that you're going to store 10 years of viewing history in 4K, that's probably not going to happen, right? That's just too much. So YouTube actually maintains multiple cookies for different users for all sorts of things like tracking what people have done, what they've watched, how far they've watched it, and holding user preferences. Again, I said one website should only be able to hold one cookie on your machine, but basically there are other kinds of data files that can fulfill the same role as cookies, but with fewer restrictions. In fact, over the last many years, we saw other objects acting like cookies while remaining somewhat hidden. Maybe the most notable of those is what was called a delayed cookie. So a delayed cookie was a long-term cookie that wasn't associated with a particular session, right? So normally when a cookie gets created, it's there to hold information about what you're doing in that particular time that you're interacting with the website until you log out. But Flash Player had one called a delayed cookie that could store a lot of information about you over a very long time. Problem was, some of that information was sensitive, and if it was stored on your machine a long time, that gave a lot longer window for bad guys to have a chance to successfully access it. And on top of that, those kind of delayed cookies were difficult to find and delete. One thing, Flash Player could arbitrarily choose someplace different to store them. And number two, they often did a sort of backup system where the system would say, well, we're going to store this data in a few different places because it's so critical. And even if you delete 1 or 2 copies, if that last copy still exists, they can use that to reconstruct the others in their original locations. So yeah, that was kind of a problem. An article here too, same kind of thing. YouTube's new no cookie feature continues to serve cookies. Basically, you can have all kinds of data files that for all practical purposes serve the same rules as cookies, but if they're not specifically classified and set up as cookies, they're not bound by the same restrictions. So anyway, yeah, a lot of these websites, in order to minimize network traffic and number of requests going to their database and how much time it takes, they like to have cookies to manage that information on the client side whenever possible. There's different ways to do that. Okay. Now, security risks. Perhaps surprisingly, when HTTP cookies first became known to the broader public in the mid-90s, number one, most people had no idea what they were, right? If grandma was using the internet for the first time in 1995 and she goes to some website and says, "Can I put a cookie on your machine?" Grandma probably thinks it's a joke. She's like, "Okay, put a cookie on my machine, sure. I don't even know what, chocolate chip, please," right? Number two, cookie acceptance was the default browser option in the 90s. So, unless you knew how to go in there and specifically block cookies and say no, ordinary users wouldn't even figure out how to do that. So when problems started to happen as far as unauthorized access to cookie data, there was this sense that a flawed technology was forced on people who didn't know any better, and people thought, oh my gosh, cookies, they're awful, we got to stop this. Now, problem is, okay, there is potentially sensitive information stored on cookies, right? And it is often encrypted, but there are various attacks that bad guys can use to still get or use that information. I have some links down there, some articles that might be interesting. But at the end of the day, blaming the cookies themselves for these kind of vulnerabilities is kind of like blaming the money in a bank for being stolen, right? That data about your site preferences has to exist somewhere. If it exists on your machine, it has to be kept in a file or in RAM, and it means that the bad guys, instead of using what they do to access a cookie, they would do some kind of similar attack to access the data in some other way. If the data is stored on the server side, number one, it's potentially still vulnerable. The bad guys could attack the server side somehow. And number two, it's going to be a definite, it's going to cause a performance hit for anything, so it'll be slower to retrieve data, slower to log into sites, anything you want to do. There's going to be more latency, or it's going to be more expensive because that site is going to have to keep more data in RAM, and to make up for those costs, they're going to have to show you more ads, which nobody's going to like. So, there's no free lunch. Cookies have been a target of various attacks, but cookies themselves, it's just the data. Okay, now, different types of cookies, there are basically three. So the standard one, or first-party cookies, those are used by the same site you're visiting. So for example, you go to YouTube, you watch a couple videos, you update your site preferences, YouTube takes that information, stores it in a cookie, and only YouTube looks at that data, and it does it, next time you go to YouTube. So that's what a first-party cookie is. It's used by the site that put the cookie on your machine. A third-party cookie is where another site gets to use the cookie. So you go to Amazon, you browse around for a while, you add a few things to your shopping cart, you leave without buying stuff. That cookie information about what's in your shopping cart, that's going to be there on your machine. And if you go to another website that's running Amazon's ads through Amazon's ad API, then Amazon can potentially authorize that site to go in, look at that cookie, use that information on pages of that other website, not Amazon, to show ads that say, hey, I saw you had this stuff in your shopping cart, maybe you'd like to go back and buy it, okay? That's a third-party cookie. The cookie data is being used by a site other than the one that put it on your machine. The last one is super cookies. So super cookies are not true HTTP cookies. Like I said, there's a lot of different ways that you can store application data on your machine besides using just these standard cookies. Super cookies, the issue with those is you often have sites that are actually like a cluster of related websites. So Google is one, right? You can go to Google, you can go to Gmail, you can go to Drive, you can go to YouTube. All of those things are kind of part of the same Google family. So if you're bound by the usual stricture of one website per cookie, one cookie per website, that's not really going to work. You'd have to do separate cookies for each one of those. But Google says, you know what, we can take that data, we can aggregate it together into what's called a super cookie, and then when you're logged into Gmail, you can automatically be logged into YouTube or Drive or whatever. Okay, so that's what super cookies are. And that information can be aggregated not just across websites, but also across different sessions over time, even different browsers, even different machines. Okay. Now, On the horizon, what's going on in the near future? Number one, cookies are still useful. They're not as useful as they once were because people's hardware usage has splintered a lot. So if it was 1995, people typically only had one machine, and it stored all the data about all the stuff they were doing on the internet. But now you've probably got, you've got maybe a desktop at home that you don't use much, but you use once in a while. You've got maybe a laptop or two. You got a smartphone. Maybe you got some kind of smart watch that does internet stuff, right? Each one of those things has its own separate batch of cookie data. On top of that, so they're only getting like a fraction of your actual online, interactions. Number two, there's a lot more privacy conscious users that are periodically going to clear all the cookies off their machines, which means cookies can gather data only over a shorter window. And finally, for a lot of things, apps are replacing cookies, right? So a lot of things, you don't go to a website anymore, you use an app on your phone, and it's not really using a cookie then. So one of the things that's replacing cookies is something called fingerprinting, right? And just like everybody supposedly has a completely unique batch of fingerprints, different from every other humans, websites can use things like the browser you're using and its version, the operating system you're using and its version, even any hardware features like your graphics card or how much memory you have or your screen size. Put all those different factors together, and yeah, there's quite often enough uniqueness to uniquely identify site visitors. So it's kind of a neat thing. So even though they're not really storing cookies, they can store that information on the server side and says, oh, your fingerprint profile matches what we know. And it can even include behavioral things like how fast you type, stuff like that. So the links I have, they're pretty old. They're like they're about 10 years old, but it said at that time about 5% of the biggest websites in the world had actually been implementing fingerprinting. And I'm sure with the decline of cookies, the number has gone up, although I haven't tracked the numbers that closely. Okay, and that's all I got for today. It has been a hoot. We'll come back on Thursday. We will have a review session, and it will be very, very useful, I hope. And that's all I got. I got to go take care of some paperwork business. I'll see you.